Hello. You've taken your test. Now we're going to do the square root property. It's a quick lesson with a quick homework. For any number n greater than 0, if x squared equals n, then x equals plus or minus the square root of n. For example, x squared equals 16. Using the square root property, x equals plus or minus the square root of 16, which means it equals plus or minus 4. We can check both of those answers to see 4 times 4 equals 16 and negative 4 times negative 4 equals 16. Another example of an equation with an x squared in it is 3x squared equals 27. If we divide both sides by 3, we will get x squared equals 9. Using the square root property, if we take the square root of x squared, because it's a variable, we're going to include both the positive and the negative solution. So plus or minus the square root of 9, and that equals plus or minus 3. And if we check those answers, 3 times negative 3 squared, we're putting it back into 3x squared equals 27. If we put negative 3 in, we will get 27. If we put 3 in, we will get 27. So both of those solutions work for this equation. So you're going to be solving these equations with an x squared in the equation. And look, here it's not equal to 0, it's equal to 16. So we're not going to factor it like we normally do. We're going to use the square root property, taking the square root, essentially, of both sides. So let's look at example 3. The quantity x minus 2, that whole quantity squared equals 25. Taking the square root of both sides leaves x minus 2 on this side and a plus or minus square root of 25 over here. We have x minus 2 equals plus or minus 5. If I look at this equation here, x minus 2 equals plus or minus 5. I'm going to look at each case of solving for x. X minus 2 equals 5 is the first case, and I add 2 to both sides to get x equals 7. X minus 2 equals negative 5 is the second case where I'm setting it equal to the negative 5. So x equals negative 3. And then I check the answers over here. Here's another example. X squared equals 5. If we take the square root of both sides, we get x equals plus or minus the square root of 5. Now, 5 is not a perfect square, so we will leave 5 in the radical sign. And the answer will be plus or minus negative 5. The next example is x minus 3 squared equals 7. Square root on the left side leaves x minus 3, but that's going to be equal to plus or minus the square root of 7 on the other side. Adding 3 to both sides gives x equals 3 plus or minus the square root of 7. If you had 3 plus the square root of 7 and 3 minus the square root of 7, that's okay too. They mean the same thing. Well, I'm going to do some examples. X squared equals 49. To solve this, I can take x, the square root of x squared, and that makes x. But it's going to be equal to plus or minus, well, the square root of 49 is 7. So x equals plus or minus 7. B, before I take the square root of both sides, I'm going to divide by 2 and get x squared by itself. Dividing both sides by 2 gives x squared equals 16. And then that leads to x equals plus or minus 4. For letter C, taking the square root of both sides, x equals plus or minus the square root of 11. For D, x minus 3 equals plus or minus the square root of 4, which is 2. I'll go ahead and write it like that. But it's x minus 3 equals plus or minus 2. Now, I want to get x by itself, so case 1 will be that x minus 3 equals positive 2, which means that x equals 5. And case 2 will be that x minus 3 equals negative 2. Adding 3 to both sides, x equals negative 1. And there's the two solutions for letter D. Letter E. Take the square root, x minus 1 equals plus or minus, well, the square root of 1 is 1. Now I'll do this case by case. X minus 1 equals positive 1. X minus 1 equals negative 1. Adding 1 to both sides, I get x equals 2 or x equals 0. Letter F. Before I take the square root of both sides, I'm going to get this square rooted quantity by itself. So I'll divide everything by 2. And I'm left with x minus 4 squared equals 16. I take that square rooted is x minus 4. And that square rooted is plus or minus 4. Case 1. X minus 4 equals positive 4. Case 2. X minus 4 equals negative 4. If I add 8 to both sides, I get x equals 8. If I add 4 to both sides, I get x equals 0. And those are the two solutions for letter F. I'm giving you a few minutes here to try this one on your own. But I'm going to go ahead and do it. You can pause it if you like and try it and then check. In fact, on all of these, you could pause it first and then check. Taking the square root of this side is 3x minus 2 equals plus or minus 2. I'll do this in two cases. When 3x minus 2 equals positive 2, and when 3x minus 2 equals negative 2. Adding 2 to both sides, 3x equals 4, x equals 4/3. And here adding 2 to both sides, 3x equals 0, x equals 0. And those are the two solutions for letter G. If I put 0 in, I'm just going to check. If I put 0 in for x, I get 3 times 0, which is 0. So minus 2 squared is 4. If I put 4/3 in for x, I get 3 times 4/3 minus 2. That cancels with that, so I get 4 minus 2, and that whole thing is squared. And that is equal to 4. So both of those solutions work. The last one, again, you could pause and try it first. 2x plus 5 equals plus or minus 15. That's the square root of 225. Try to memorize those perfect squares on your homework. I have you practicing those. Case 1 will be 2x plus 5 equals 15. And case 2 is when 2x plus 5 would equal negative 15. Solving for x, subtracting 5, I get 2x equals 10. Dividing both sides by 2, give x equal 5. Over here, 2x equals negative 20 if I subtract 5 from both sides. X equals negative 10 when I divide both sides by 2. And those are the two solutions, and I'm going to check those. If x equals 5, that's 10 plus 5. 15 squared is 225. If I put negative 10 in for x, that's negative 20 plus 5. That becomes negative 15. Negative 15 squared is also 225, so they check. Flip over your paper and you can start the homework.